Hello everyone, welcome to today's Novedge webinar, From Scan to CAD, 3D Reverse Engineering with Mesh2Surface. Join this webinar to find out how to convert 3D scan STL mesh data into professional CAD models. Mesh2Surface's product manager will present you all the tools of the software to align the model, extract fitted surfaces, and build a complete CAD model with simplicity and speed. Mesh2Surface is especially designed for 3D reverse engineering. It is highly efficient, user-friendly, and precise, all at a very affordable price. No matter how small or large your projects are, it is something not to be missed. So stick around. Let me tell you a little bit about our presenter today. Kostadin is a product manager of Mesh2Surface, and he has been with the team since the beginning in 2010. His specialties include 3D scan processing, creating 3D scan algorithms, as well as designing the product. Fun fact, Kostadin was also a key member of the team who built the first handheld 3D laser scanner. Great. And let me tell you a little bit about Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's need. So put us to the test and visit novedge.com. And let me show you where you can also find us on Facebook, Twitter, Instagram. We're all over the social media, so like us to find the latest new and announcement on special promotion. Next webinar will be about a software for interior designer. It's called CAD, brand new in our catalog. It's in 2 weeks. And to rewatch today's webinar or previous one, check out our Novedge YouTube and Vimeo channels. I will be recording the webinar and post it as soon as the live demo is over. And now, without further ado, I'm going to share Costa's screen so we can walk you through Mesh2Surface. Okay, hello. I can see your screen. Take it away, Costa.
Hello, everyone. As any presentation, I would like to go first with a short PowerPoint and telling you a bit about us. So, who we are first. Mesh2Surface is a piece of software developed by KVS Limited, which is a spin-off of a company, Ada3D. Ada3D is a Bulgarian company which is known in the 3D scanning industry with the fact that we participated actively to build the first handheld scanner. I just found this image from the internet, but it's in reality the picture of our first scanner, which we mounted on Faro bronze arm. At that time, it was a challenge to handle many points, put it on the computer, Pentium, 400 Hertz, and you see it on the picture back from 1996. And at that time, we've been developing a lot of algorithms, how to handle all these point clouds. We experience in this area a lot. Now this scanner is known as Nikon Model Maker. Why we did our piece of software, which we called Mesh2Surface. During these years, we've been visiting a lot of exhibitions, and people were passing by our stand and looking at the screen because we were doing real-time rendering of the scan points. They were coming next to us and said, "Whoa, that's a CAD model. Can you give it to me?" It was taking us a while until we explained them that it's actually not a CAD model, it's a point. All these people coming from the previous generation knowing only about the CAD modeling, it was the first time they see this. So it was really hard to explain to them about this. In fact, reverse engineering, it's a difficult process. What I found over these years, there is no universal solution. Every object, every project is individual. It's also time-consuming. It takes a while to do even a little things. So this inspired us to start and doing this software Mesh2Surface. In fact, what is Mesh2Surface? We designed a couple of tools to simplify the whole process. The reverse engineering is a tedious job. You know, as you see on the image, even this small and simple shape, in order to recreate it, you need to define the cylinders, planes, and this takes time. But in fact, based on our knowledge, we added our experience, we added algorithms to actually keep the accuracy during this process. So we incorporated our best fit algorithms, plane fits, cylinder fits, etc., which I will do a demo a bit later, in order to efficiently reconstruct this in a simple way, but at the same time not compromising with the quality. Many people were showing me data like the one on the left side, which is a perfect model, which is a perfect mesh, which probably comes directly from the CAD model or probably ZBrush. I would say that our software is not designed for this. Its power is more about to apply fitting algorithms on the noisy mesh data to get the best of it. Before moving further, I would like to say a few words about the tolerancing. And it's just try to explain about what is going on in the real world. If we take the picture on the left, this is the ideal world. Let's assume that we have a part with a hole, and this is a perfect circle with a given radius, for example, 10 millimeters. In reality, the objects, they are never like this. In the real world, they can be bent, can be damaged, and then it comes to the technology. The technology can be contact or non-contact scanning or CT, anything, but because it's a physical world, it never comes perfect. As you see on the third picture, the points we get is like this. So then if you look at the specification, if you speak with the guys who sell the scanners, they start talking about the 1 sigma, 2 sigma, accuracy, and all of this stuff, which is good, and everyone wants this to be minimal. But the reality is that up today, the general mid-range scanners, we are talking about between 20 and 50 microns, which means that if we give this object to the designer and he needs to do reverse engineering, he needs to decide what actually is needed. Is it the yellow circle or it's actually the red one? Which one is the correct one? So there are many questions. Mesh2Surface actually helps you in this reverse engineering process to keep control from the beginning until the end and to save time by identifying the problems at the early stage, which will lead to designer to speak with the customer, take decisions, and actually this is what I call it design intent. Why it's so important? Well, if you see the object on the left side, it's a mechanical part, and of course we can define the bottom plane by picking just 3 points. In any software, mathematically, we only need 3 points, but is it actually correct? So if you don't define properly your shapes, you may end up like in the picture on the right. And a few words at the end to say that our software Mesh2Surface is actually a plugin in Rhino. There are a couple of reasons for doing this. First of all, we want to stay as close as possible to the CAD system. We found Rhinoceros very affordable in terms of price, and combining with our solution, it's times cheaper than any other high-end packages. And at the same time, the development team provided us with a lot of help and support. And because we know that the reverse engineering is just a part of the whole process, we decided to stay as close as possible to a CAD system. So that was end of my presentation. I would like if we can just move to the real demo, because this is the easiest way where we can explain and show what it's all about. And I will just start with this simple object which has a lot of primitives. I just loaded it in Rhino. The object has been provided to us by Patrick Thorne, which is our partner in UK, and the scan has been done using Artex scanner. So we normally get this type of shape, we put it in our environment, and the first thing we see is actually that it's not aligned. It just stays in space. If you're using a scanner like Faro with the touch probing, you can do a dataming and you can align this object in the space, but in other cases like Creaform, Artec, on any other non-contact scanners, it's really difficult. So they just put this object and said, okay, make a reverse engineering out of this. So Mesh2Surface is a plugin, has its own menu. So the way it works, we just select this STL mesh and we want to start working with it. For the simplicity, our software offers you to put this in a separate layer. It's just for ease of use. Our Mesh2Surface has its own environment. We decided to do this. The navigation of the 3D view is very similar to Rhino. So you can do and move with the mouse and manipulate the point. You can also see the coordinate system. It's in a very similar friendly environment. There is another reason for this, because once we create the shapes and we save the file, these shapes stay in the project. So at any point in time, you can come back, modify them, adjust them based on your needs, and put them back and recreate the object again. So let's try to see what we need to do now. We have a couple of tools to create selection. One of them is just by painting on the screen. With the Alt key, we just remove selection. But my favorite one, and the most common for the primitive shapes, is the magic wand. In fact, this is based on the angle here, so you can play with the sensitivity, and in such a way you can select an area of your interest. For example, I can simply select an area which is my plane in this case, or I can click on the side, and if I play with the slider, I can just get the points which are defining my extrusion. I can add up another selection, etc. So let's start with this plane. I'll just select this area. And I'll just, if I click middle mouse button, it gives me a shortcut, but you can always come and say from the plus sign, and I say this is a plane. Now, we'll very quickly, the software defines a best fit plane now, but we have a tool which is called deviation. So I can always come and see my result now. I can provide, as I said in my introduction, about the tolerance. The tolerance is something which people accept. When you work with the STL meshes coming from non-contact scanning technologies, it's always about this tolerance. What is something which you'll be happy with? So in this current example, I just put a 50 microns, which is 0.05 millimeters. And then you can see that now this is, my plane is what I want. Mesh2Surface has some simple tools to align the object in space. So we have a couple of commands here, which you, based on the current shape you have, you can just say, okay, I want to align this to my bottom plane, which is in fact XY plane mathematically. If I take a look, it just aligned. Because the plane has normals, we don't know actually what is the right way to align it. So if I press it twice, it will just flip the orientation. And now if I see from the top, I can see that my plane is exactly what I would like to do. Also, there is a shape panel, which you can adjust the parameters of any shape. I'll go in details how to play with this in a minute. So now what we have is we align this object, but still this is not suitable for our purposes. So if I take a top view, I will start and create a new shape. Mesh2Surface has a command which is called a shape which is actually called Symmetry Plane. How this works: if we select part of the object in the middle, which actually defines our two halves, and if I select a symmetry plane, the algorithms try to find the symmetry of this object. What happened now is, because I didn't delete the previous selection, our current selection didn't manage to find the right symmetry plane. So I'll put it again on the top view, clear everything, all the selections. I will delete the symmetry plane. It's not. Make sure I don't have anything selected, and then I will select roughly where my symmetry plane should be. I can define the symmetry plane, and now it looks much better. It tries to minimize the distance based on the best fit algorithms where the symmetry plane should be. And then you have a handle which you can tweak and adjust your symmetry. In this case, I was not really successful. I will do it again. You can play with the maximum distance to search and how many points to use for this algorithm. I try to build the proper results. So I'll do this manually somehow. So it looks like that the object is not that much symmetrical. But anyway, it's good for this demonstration purposes. So now I have my symmetry plane. And what I can say, okay, put this as my ZY plane. So now we almost aligned the object as the way we want it. I will go to a new shape and we'll continue further. Let's take a look now that the object is aligned to the bottom plane, but actually where the center should go. Now it comes the question, what is our guiding cylinder here? We may choose this outer cylinder for a guiding axis, or we can choose this one. And here what Mesh2Surface helps you with, you can go and speak with your customer and discuss how to approach all this. In my case, if I get the outer cylinder, I can create the cylinder. We have handles for every shape, which you can adjust. And now let's see what happens with this cylinder. Again, we have this deviation analyzer, which gives you how the cylinder is fit to the points, and I see they're pretty well. So, in fact, what we have now, we have the plane, we have a cylinder, and basically how the reverse engineering works, we just take this plane, create it in Rhino, take the cylinder and put it in Rhino. So I can, let me just hide the mesh. And here I can do a basic trim operations to create my object. I can take this one and trim, and this looks nice. And people may take this and deliver this as a, I'll just remove this word flashing, sorry. And now it looks okay, but the thing is, the biggest problem is that it's actually not correct. This plane is not perpendicular to the cylinder. And this is where, again, Mesh2Surface can help. Why? Because in this case, I may come to the cylinder panel and I have a lot of controls how to do this. We have what is called constraint fitting. In this case, I may tell the software that I would like to find the best fit of this cylinder, but at the same time keep my direction perpendicular to the plane. And now the software fits the cylinder, but make sure that it's perpendicular to my bottom plane. I see that this is not used, it's not aligned to the bottom plane, so now it's exactly the z-axis of the normal of the plane is 1. So as you see now, the cylinder is what we wanted. So we can easily now tell the software, okay, now put the software, the object, so the axis of the cylinder is on my global coordinate system. So now we have aligned this correctly, the way we want. Again, if I take a look further, this cylinder is nice, but here we have a revolved surface, so maybe it's more appropriate if we define the small cylinder, which will be guiding us for our revolved surface. So I'll create a new shape, we'll take the inner surface by clicking, we'll create my small cylinder. Again, we'll clear the selection, delete. We'll take only the inner part, create a cylinder. And now I will say, make it to the plane. So you have a correct normal. Then I can always come and check the deviation. Is it good? You can interactively move and see the deviations, which are okay in my case. And then I can say, okay, now put this into in such a way that my z-axis is going through the axis of the cylinder. So this was in general our preparation to start the reverse engineering. How can we proceed further? Mesh2Surface provides a couple of tools to create extruded and revolved surfaces. So I'll go into the new shape, and as I see on the screen, this is my revolved surface. I will select this part. If I will put in front view, and if I don't want the top because it's part of my revolved surface, I will just choose my paint selection. I will hold out to remove these points which are not needed. And now I can define my extrusion. How the extrusion works, it tries to find the best fit and find the orientation. And in this case, it's really hard to predict the orientation, but I know that it's vertical, so I can say, okay, use the direction from my cylinder. So now the direction of the extrusion is exactly what I want to. As we all know, the revolved and extruded surfaces, they use sketching. So Mesh2Surface also helps with this. You can go in Sketch and you see actually your extruded surface. This has been extracted because I didn't remove the selection from my previous cylinder, but it doesn't hurt. So I'm coming here and I can delete this line, and then I can start creating my sketch. We have a simple line and arcs commands. So you can come and define your lines here. And also you can get and create a tangent arc by picking 2 points, and you can move this. Why it makes this snapping now is because I have this snapping distance set to 0.01 millimeter. This, in fact, doesn't allow us to create a different values of what we want to. In this example, 28.55. This is important because when you do manufacturing, you don't want to get the values which are 28, 51, 35, several digits after that. So that's why we use this rounding to control this. So now, as we see, we can get up to the third digit, and this is what we achieve. We can always come back to the shape and see what our result is. Of course, we can go to deviation, and the deviation shows us how close we are to the object. For this demonstration, I did it very quickly. It wasn't too precise, so that's why you get a huge deviation here. But you can always go to the sketch, take this line, and adjust the way you want it. The other way of doing it, I will just delete my shapes, is just if you hold the Shift key and if you just select a couple of points, it will make a best fit of your line. So now it's much easier, and I will just take a tangent arc and I will come and define it. So I hope that now the Deviation Analyzer will show me the result much better. Here, the question is why we get these results. Based on what I see, I would say that probably the shape is deformed. It's been plastic shape. So again, this is the design intent. What do you want to do in this case? You can show this to the customer and make a decision to go further. For the extruded surface, we have handles also to make it longer or shorter, and we can move it up or down. So in fact, this is how the primitives work. So I'll just create quickly another simple shape by taking this plane. Again, I need to take care about the selection. So I select this plane. You can play with the selected points, how many points you want, and then you can define your plane. Let's take a look at this deviation. It looks okay, but again, the design intent. If we take a look, the direction, the orientation of this plane, it has some weird numbers, but we want that this is actually parallel to the bottom plane. So that's why we can always put a line as a plane at the bottom plane. But in our case, because we oriented it to the XY plane, we just can say, okay, make it horizontal. So as you see now, the plane is perfectly parallel to our bottom plane. But if you come and see the deviation, it's completely different. So here is now is the point you go to the customer and say, okay, what should we do in this case? How we can compromise? Can we keep this distance between the bottom and the plane to 8.8866, or you want something which makes sense to you? You can take a screen depth of your deviation, and you can go there and discuss this with them. So how we actually do after that, we create this in Rhino. You can put this shape, you can take all the shapes and put them there. So let's go a little bit in the revolved surface. I will just create a new shape, and if I look on this part, it's actually a revolved surface. The revolved surface works in a similar way like extrusion, but you need an axis for the rotation, and again, you just select what you expect, and I will just select front-facing only mode, just to make sure I don't select anything from the side. I select some points. Also, from what I see on the screen is that the top part is also part of my revolving surface. So I have what I need, except the top, so I can put it in front view. Now I want to have selection through a whole object. And then I can say, okay, make a revolved surface. The revolved surface tries to fit a cone from what we selected, and it not always provides the exact result. But in this case, what we know is that the axis of rotation is actually my z-axis. So I can easily say, okay, use my z-axis as orientation to define this revolved surface. But also, please go through the origin. Now I'm sure that this revolved surface is properly defined. So I can go in the sketch and I see my point, which will define the revolved surface. As you see here, we see many points. And why is that? When we define our revolve surface, actually we take and make many cross sections. It's not a single one, but a lot more. Why is this? Because of the world of the 3D scanning and inaccuracy, we need a lot more representation of the object in order to get the optimum shape. So if I take only one section, this is not representative enough for me. But if I have 20 sections now, I see that there are many points here on which I can work on. So here I can do just a bit of a trivial stuff. I hold Shift, select and define my line. I can select this part. I can make it vertical as it's my design intent. I can come and say, okay, make a tangent arc here and put it as close as possible. And or you can just draw, okay, you can just draw lines here and define a tangent arc. I will not go into details, but this is what we get. Now, again, before we actually proceed to reconstruct our object, we can always go to deviation and see what's going on. And our state-of-the-art, very fast deviation analyzer shows you immediately on the screen what is your object. As you see now, because I initially aligned my object based on this small cylinder, which was this little one, my revolve surface is not what I expect. So again, this is an indication for me to go and speak with the customer and understand why is this and why this cannot, what we need to do with this. So this is generally the basic shape extraction in Mesh2Surface. You can extract spheres, as I said, extruded revolve surfaces. And the process after that, how it works is you just take all of them, put them in Rhino environment by creating these shapes, or you can just create all in Rhino and then you start with the simple trimming. I know it looks weird now, but you need to have some basic knowledge in order to do this. But then you start doing a trimming operation. If it looks too complicated now, you can just do it one by one and reconstruct the object. So in fact, by doing this, we end up with the model which we have. I will delete this, which is the model I created before this presentation, which looks like this. Now, I would like to say a few words about our Deviation Analyzer. Deviation Analyzer is our fast and efficient comparison tool, which is not tightly related to our process. What I mean by this is that you can take any CAD model and any mesh, and if they are aligned, you can very quickly go and apply the Deviation Analyzer and see your displacement between the nominal data and the mesh. And this is kind of an inspection. So I can come and just take labels, and you can see the screen on the screen, the displacement. Also, you can always come and capture this point into the clipboard, and you can create a documentation. You can paste this in the Word document, give it to a customer, and discuss it with him with all the numbers. And in fact, it's a lightweight inspection package. I would like to move to the next model, which is a partially scanned impeller. You may probably have seen this in our videos. This is a part which has been provided to us by our partner in UK, ThinkScan Solution. And why I'm showing you this is that Mesh2Surface doesn't require a closed mesh. Even if you scan partially a mesh, or even if you have holes, or even if you don't have the full object, you can always use all the information you have, and you can, from this one, and you can create a complete model. And very briefly, to show you some advantages in this case, if I take a look at this object, I see that it's already aligned. So my client has, during the scanning, has defined properly my center of the object. So here, the way it has been reverse engineering, you just get revolved surfaces at the bottom, you get the other revolved surface here, and then you have patch command, which I'll show you on the different object, and then we have this revolved surface. I just wanted to focus a little bit why this is interesting. This revolved surface is defined only of this little contour here. Even if we define the revolved surface, and if we make a single cross section, this is not enough for us to define what we expect. So in this case, I use 20 sections, and I will delete this for the. If I use only 5 cross sections, for example, and rebuild, you see that I even don't get any points now. I don't know what's going on. Where is my profile? But I can put 20 or 50 sections, and if I rebuild my information, I can come and actually I get all the information I need. So how we reconstruct this, I can come and select with Shift, and this will make a best fit of my line. And now is the time to say a little bit more about our tolerance tool. Our tolerance option is a powerful tool of real-time color plotting and what some people call heat map or color map, which will give you what is the distance, how our reconstructed shape is against the scan point. So we enable this option by this checkbox, and the options we have is what is our tolerance, how do we work, what we expect. And normally just people put their tolerance. Some of them can be tight tolerances, 10 microns or 5 microns. Some of them can be huge if they scan buildings. And you can see this in gradient scale or in the pass-fail scale. Pass-fail is actually yes and no. I personally found when I work with the sketches that pass-fail is much better, the gradient. So this how this works. If I enable this option, I will just move, and it shows me an area whether how close am I with to the surface. One other tool which we have in 3D sketching is a curve shape, and this is actually a cubic spline where you can pick points on the screen and you can define your shape, and you finish it. So now you obviously see what the power of this tolerance option is. If I just come here, I can see that this is out my tolerance I can take, and this will insert the point, and I can get closer. And in this way, I can just adjust my shape in such a way that it's as close as possible to the surface. For example, here, if I want to make a tangent arc, I just start doing this. And as you see, Mesh2Surface interactively shows you how far you are from it. And I'm ready. What I'm doing on the screen, this is the seam line of the revolved surface, which is important for the trimming operations. And you put this in Rhino, and then you create your surface. And this is how we create our impeller. I will just delete my surface. This is my result. So in general, this is for the basic shapes, how we can reconstruct purely mechanical parts. But Mesh2Surface also has power if you want to do a freeform surfacing. So I'll move to our a bit more organic shape, and I would like to show you how Mesh2Surface can help you to convert this shape into this CAD model. So I will start again taking this model and put it in our environment. If I analyze this, I see that it's kind of aligned. I mean, it's vertical, which is okay. If I look at it from top, it's not in the center, the axis, but in my case, it doesn't matter. Then I have several shapes here, which I will delete them and will create them from scratch. So I will choose my top surface and will reduce a bit the selection so it doesn't influence my shape. I will take and remove some of them here. So what we have in our software is the patch command. Maybe some of you know it as a function which exists in Rhino. In fact, in the background, we use the same command, but we add here kind of other intelligence, which means is, okay, what parameters should I use? How can I define this surface? So again, we're talking about tolerances. What do we want to achieve? How well we want to fit this patch to my surface? So here the user has this control to put how close this surface should go to. And then the software automatically increases the number of UV points until it achieves this, this result. For example, here by default it's 0.1 millimeters. And if you go to deviation, you can see the results. But you can say that you may want a tighter tolerance, and then you get these results. Of course, if the tighter we go, we get more details, but then the shape may not be smooth enough. So that's why the user also has some options here, how he wants to fit this, whether he wants a smoother surface or he wants to get as close as possible to the data. It's really up to the user how to do this. So I have this shape now done. I will move to the next one, and I've done this project, and unfortunately we need to create a plane here. I can just pick some areas which will define my plane in the front. I will create a plane which will trim our surfaces. And I will move further. Now this is the freeform. How I can move to it. So this is where our 3D sketching tool will help a lot. 3D sketching is just provides some simple tools for you to draw lines on the object. You just come here to this mode and you start drawing this by picking points on the object. I know that you can do this in Rhino, but I will show you what is the difference now. I just pick and create 4 curves here on the object. Almost ready. Very roughly, I created 4 curves here on my object. And for the ease of use, we have this ghosted view, so it makes actually the shape transparent so the user can see. And now we can take a look and we can actually start modifying these curves. The difference is that we can, I have switched these keep curves on the mesh. This should be on. So in fact, when you move the points, the curves always lie on the mesh. So here, again, we have this tolerance option. As you see, by default, or because of my previous action, it just turned to pass-fail option, which I will make a gradient in this case. So you can come and adjust your curves. You can insert other points if you need to, and if you want to get as close as possible to the surface. But let me show you why it's what is the power in this case. So I have 4 curves now. I can shift click and select the 4 curves, and then I say, okay, I want to create a curve network. The curve network uses the Rhinus curve network surface underneath, and what you see on the screen is the same what you get in Rhino. Of course, this is not what we want. But how we can continue further? Now with this, with our simple tools, we can interactively improve our shape until we get the desired results. So if I hold Control, I can start and actually move my bounded, which we call it bounded curves. So in this case, I need to duplicate my leading curve and put it in the middle. So I just hold Control and Alt, and we'll pick this. Oops, okay, that's not good. I didn't pick the right one. Okay. Of course, you always have a Control-Z command. I will start again and create this surface. Okay, if you experience problems like this, it's good if you just add another curve. I'm sorry, it's just you pick. And this will automatically insert and update the surface. Okay, I will probably need to start from scratch. I will just select all curves and clear them, and we'll redo this. So if I modify now, I should be able to take this Control. I don't need this soft move, and I don't know why it doesn't work. But anyway, I will just create other curves here, which will probably will improve my shape. I can take several. They don't need to be accurate. So now if I select all the curves, and I can create my shape, and okay, this will work now. So now I can improve my shape. This looks like something that probably is what I want, but I'm sure it isn't. So how Mesh2Surface helps here? If you just hold Control and Alt, you can duplicate your curves while they keep them in the grid, if you keep them in U and V direction. And again, because the keep curves on not its own, when you lift the mouse, they just lie on the mesh. And in this way, you can improve your shape. But this may not be enough. And here is our tolerance option. Because our deviation analyzer is optimized, it's very quick, so you can in real time, only by moving, you can see what the quality of your surface is. As you see now, this is absolutely not even close to the tolerance, so I can improve my resolution by moving these curves, and I can get closer. I can hold Control to move this curve only, or I can take this one and move it, and in such a way I can get really close to what I want. When I'm ready or nearly ready, I can use my Extrapolate command. In many cases, Mesh2Surface works in a way that the trimming is needed. So the best way to do this, you just take the object and you extrapolate by taking the boundary curves which define the surface and extrude them, extrapolate them a bit further so they can be trimmed later when you finish them off. I think this is enough. And I will quickly go and try to show you how we will be in the front. Again, this is another 3D sketch. I just create a surface from all of them, and here I can take and start increasing the resolution. You can always move individual points. And as you see, the more I insert, the better the quality is. Here it's something wrong, so you can come and adjust. So the difference is, some people may say, okay, we have these commands in Rhino, why you should use this? But the interactivity is here. We keep the information, the curves are related to the surface, so you can always come back and redo your job, and you can make the surface which you actually want and which actually is exactly what you need. Again, here I will just extrapolate commands in order to make a trimming, and then I'm actually almost ready. So I can create all of them in Rhino, and I can start trimming with the normal tools. I just take this plane and just start trimming the surface. In such a way, I can reconstruct from all these surfaces the model which will actually I will delete this, will look like this. Again, you can come and use the Deviation Analyzer to see your final result. As you see here, we don't have we have a deviation here, but this is because of the trimming. So the user can always apply filleting here and to get the best result. The next thing, a bit which I wanted to show is some last what is available in our version 5. We added this is our chair, which you've probably seen on our website. We have added some extra commands like loft surface, sweep, and blending surfaces. Again, why blend surfaces? Because once you create a blend surface, the interactivity is still here, so you can, by manipulating the surface, you can always see what your object is like and how close you are with the surface. You can move the curve and you just get your result. Another thing which we have in our software is what we call a soft move command. If you enable this, the whole patch moves simultaneously, which in many cases is quite useful. Without this command, without this option, you can just move individual points to adjust them on the screen. So this is a very short demonstration of capabilities. Visit our website, take a look at our YouTube videos, and download the version and try it yourself. So Barbara, that was all from me for now.
Thank you so much, Kostadin. Yeah, the only question we had so far is if this software is a plugin just for Rhino, and as I'm sure people would like it to work for other software, but I think that's, Rhino's all you get.
At the moment, yes.
At the moment.
At the moment, we have plans to cooperate with other players. Many customers are asking us why it's not available for other, but it costs us a lot of support and friendliness with the other companies, so it takes a while.
I
And
understand.
also, again, I would like to say that our solution with Rhino, if you compare on the market, it's times cheaper even as a whole. It's much cheaper than any other software which is available.
And it's a great solution, as we just saw. So, yeah, if you have other questions, we'll stick around for another few minutes. In the meantime, I would like to thank Kostadin for this great demo. I would like to take the screen back, and I will still be waiting for your question if you have any. So, okay, we have a comment. Thank you, very powerful, and I have been using it for a bit now. Will the upgrade be available soon?
I don't understand what the latest version 5 is available
Yes, it is available actually at Novedge. So I
Yes.
think that's what they're asking. Yes, of course, come get it. And in fact, I want to show you where you can find it at Novedge. Okay, I lost the page. There it is. That's the product page, novedge.com. You can put into the search Mesh2Surface, and you'll be directed to this page, and you can take it home immediately. Thank you for attending today, and thank you again, Kostadin. I want to remind you that I've been taping this entire presentation, and I will post it on our YouTube and Vimeo channel as early as this afternoon. Thank you for joining us today. Have a great rest of the day. Bye-bye, everybody.
Thank you.